Hi, this is Mr. Mack. This is the third video on the third session notes. This one should not take too long, though. Of course, best laid plans of mice and men. Now, when you find an area under the normal curve, what you're really getting is a probability. Because remember, probabilities are 0 to 1, and the area under the normal curve from negative infinity to infinity is 1. So if we were to say z is less than negative 1.4 and get the area as 0.0808, that would actually be the probability that your z-score is less than negative 1.4. So when they ask you for p of z is less than negative 1.4, you look in the standard normal curve, find the area to the left of a z-score of negative 1.4, and that area is the probability. So some examples here, and note items in the mirror may be larger than life. No, actually, the information in each question may not be accurate in real life. The Chapin Social Insight Test evaluates how accurately the subject appraises other people. In the reference population used to develop the test, scores were approximately normally distributed with a mean of 25 and a standard deviation of 5. The range of possible scores was 0 to 41. If a randomly selected student has a score of 40, then how many standard deviations away from the mean is that student's score? All right, well, we would use the z-score of 40 would be 40 minus 25 over 5. And 40 minus 25 is 15. 15 over 5 is 3. So a z-score of 40, or a score of 40, would be 3 standard deviation above the mean. Determine the standardized value for a score of 22. Well, the standardized value for a score of 22 would be 22 minus 25 over 5. 22 minus 25 is negative 3 over 5, so we would get negative 0.6. What is the relative frequency corresponding to a score of 25 or more? Relative frequency is just a highfalutin name for probability. So we would say the z-score for 25 would be 25 minus 25 over 5, which is 0. And so if we look at the standard normal curve, we don't really have to look at the table, because a z-score of 0 below the 0 is going to be 0.5. So above, the probability z is greater than or equal to 25 is equal to 0.5, 50%. Okay, music video artists are not only the only ones who get to play around with money. The average salary for a music video producer is normally distributed with a mean of $134,000 and a standard deviation of $4,200. What's the percentage of music video producers that make more than $125,600? All right, let's do this. We want the z-score, or actually we want the probability that z is greater than 125,600. So first of all, we would compute the z-score of that value. Now let's pull the calculator up here, and so we go to town. We've got in parentheses 125,600 minus 134,000 divide, was it 4,200? Yeah, 4,200. 4,200. So we get a z-score of -2. So the probability that z is greater than -2, we can do that by the empirical formula. Maybe we should do that way. So what we've got is from -2 to 2 is 95%. And then there's 2.5% here, and 2.5% over here. So we would end up with 97.5%. Now, if we actually look 2 up on the table, and we probably ought to do that, if we actually looked up 2 on the table, it would be here. We get 0.9772. So 0.9772 would be the values, all the values to the left of 2. So all the values to the right of -2 would also be 0.9772. So if we use the table, we get 97.72%. If we use the empirical rule, we get 97.5%. Now that is really pretty close, but you do need to pay attention to whether or not you should be using the table or using the empirical rule, because the empirical rule is an approximation. All right, question number 5, or example number 5. We have a real estate agent working entirely on commission. Now, this agent makes an average of $850 with a standard deviation of $260 weekly selling property in the city. If we assume this distribution is roughly normal, what is the probability that the real estate agent will make between $110,000 and $1,110 and $1,630 selling property in the city? All right, so let's take a look at the standard normal curve. Now we've got 850 right here as the average. So 1110 would be here, and 1630 would be somewhere over here. And what we're interested in is the area of this region, because we're asked for the probability that the agent will sell somewhere between that amount. So we need to know the z-score for 1110 and the z-score for 1630. Let's do each of those on the calculator. I seem to have lost my calculator. There it is. Okay, so we have 1110 minus 850 divide 260. And we get 1. Okay, so the z-score here is 1. And 1630 minus 850 divide 260 is 3. So once again, the empirical rule would probably get this for us, but let's go ahead and use the table. So the z-score for 1, or the area for a z-score of 1 is going to be 0.8413. And the z-score for 3 is going to be 0.9987. So the probability, or the area between those two, would be 0.9987 minus 0.8413. Starting 7 minus 3 is 4. 8 minus 1 is 7. 9 minus 4 is 5. And 9 minus 8 is 1. So 0.1574. Number 6. The length it takes a teenager to respond to a Facebook update is surprisingly normally distributed, with a mean of 4 hours and a standard deviation of 23 minutes. What is the probability that a recorded time will not be in between 217 and 286 minutes. So let's take a look at this standard normal curve. Now, 4 hours is the mean. That's 4 times 60 is 240 minutes. So 217 minutes would be below, and 286 minutes would be above. And so we're asking for this area and this area. Now, we can find the probability that z is less than, okay, now first of all, the z of 21 or 217 would be 217 minus 240 over, what was the standard deviation? 23. So let's just get our calculator. And we have 217 minus 240 divide 23. And we get -1. Okay. So and the probability, or let's see, z of 286 is going to be 2. Surprise, surprise. Now, the probability that z is less than -1 can be read right out of the table. .1587. And the probability that z is greater than 2 is going to be 1 minus the probability that z is less than 2. And so let's put that down here and go back here. We're looking now at 2.9772. Which turns out to be 0.0. Let's see, what is that? Let's start over here with the 8, 7 from -2, 7 from -2, 9 from 9 is, so 0.022. So if we add these two, 0.1587 and 0.0228, these are the two places where the response time will not be in the range from 217 to 286, and we get 5181. 18.15% would be the probability that the recorded time wouldn't be between that amount of time. All right. Let's go on to number 7. The length of pregnancy for Asian elephants has an approximate normal distribution with an average length of 609 days and a standard deviation of 31 days. How long do the longest 5% of all elephant pregnancies last? Okay, first of all, let's look over here. We have 609 here, and we've got a standard deviation of 31 days. Okay, so what we want is how long do the longest 5% of elephant pregnancies last. Now that would be this region over here, and the 5%, actually 0.05, or the 5%, 0.05. Let me erase that and just do that right. 0.05 would be this region here. Now that would make this region from here on down 0.95. Now it's tempting to say, well, we can use the empirical rule, but this is not the symmetrical value between plus or minus 2 standard deviations. This is from a z-score all the way down. So now what we're going to do is we're going to go back to the table and, oops, I went the wrong way, I think. We're going to go back to the table, and in the base of the table, or in the table itself, we're going to look for 0.9500, 0.9505, 0.9495, 0.9500. It's actually about halfway between these two. So let's take a look at what that would be. That's 1.6, and that's 0, 1, 2, 3, 4, 5. So 0.065, or actually we could probably interpolate that and make that 0.0645. It's halfway between 4 and 5, so 0.0645 there. So let's just use that value for the z-score. Okay, I think we're on the next page. No, we're not. Oh, yes, we are. 0.06. No, we're not. Yeah, we are. Here we go. So you know, it's not 0.06. What did I do wrong here? $1.645. Okay, now that makes more sense. So the z-score here is going to be 1.645. Now we're still going to use that equation. Now the equation is the z-score 1.645 is equal to x. Now we don't know what x is. That's what we want to know. Minus x bar, which is 609, over s, which is 31. So now to solve this equation, we need to solve for x. That means we multiply both sides by 31 and then we add 609. So I get 1.645 times 31 plus 609 is going to be equal to x. And we'll just ask our calculator to tell us what that is. And we get 659.995, so 660 days approximately. 660 days approximately. What percent of elephant pregnancies last between 600 and 615 days? All right, now once again, what we want here is, here's 609, here's 600, and here's 615. And what we want is this region here. So we're going to have to find the z-scores of 600 and the z-scores of 615, and then we're going to have to find the table values for those and subtract the smaller one from the larger one. So parentheses 615 minus 609 divide 31 gives us 0.1935. So to the nearest hundredth, that would be 0.194. Now, 600 minus 609 over 31 is negative 0.290. So now back, to what? First of all, let's do 1.194. So 0.194 0, 1, 2, 3, 4, 0.9738. And negative 0.290. .0019. Did I do that 0.194 right? I don't think I did. 0.194. No, I didn't do that right. Where is that? 0.194. That would just be here. 0.5714. Okay. That's 0.19. And we drop the 4 because it's less than 5. So 0.5714. So now, to get in between, we have 0.5714 minus 0.0019, and we get 0.5695, I think. Yeah, so 56.95% of elephant pregnancies last between 600 and 615 days. The shortest 20% of all elephant pregnancies last fewer than how many days? Okay, so now we want the shortest 20%, so 0.20 here. So we're going to look in the table for 0.20. So we're in the table here looking for 0.2. Oops. 0.20. This one looks to be the closest. We look up at the, okay, we look over on the left-hand side. We have negative 0.8. That's 0, 1, 2, 3, 4. Negative 0.84 is the z-score. And so now we're going to change that into a number of days. We have negative 0.84 is equal to x minus 609 over 31. So we multiply negative 0.84 times 31, and then we add 609 to that, and we get 580.44. So about 580 days. And last but not least, the middle 50% of all elephant pregnancies fall between how many days? Okay, let's just extend this a little bit and draw ourselves a picture again. Now this time we have the mean, which is again 609 days, and So we want the region in here to be 50%. Now, what we could do, and this might make our journey here a little bit easier, we could notice that we want the middle 50%, so there's actually 25% here. So we want 25% to be here. So if we could find the z-score for 25%, then the z-score for 75% would be just the positive of that number. So let's go to the table and look for a z-score of 25%. And that's going to be here. And we find our circle, and we're going to 0.25. Actually, we were pretty close. 25, 24, 2514. Let me move this up. 2483. Now this is 14 above. That's 17 below. So we'll just pick this one for right now. I don't know if we're going to be talking about interpolating or not. So that is negative 0.6, 1, 2, 0, 1, 2, 3, 4, 6, 7. Negative 0.67. So what that means is the z-score here is negative 0.67. The z-score here is positive 0.67. And so all we need to find is the two values that are those. So we have negative 0.67 equals x minus 609 over 31. And we have positive 0.67 equals x minus 609 over 31. Now on the first one, we're going to multiply negative 0.67 times 31, and then we're going to add 609. And that gives us 588. So this is 588th day. And then we're going to do the same thing again, but with a positive 67. It doesn't get much better than this, folks. Just delete that negative sign and press enter, and we get 629.77. So 629, actually 630 days. So the middle 50% of elephant pregnancies fall between 588 days and 630 days. And we're done.